Hello, everyone. Welcome to the Selenium conference, day 1, and my track. I will be talking about leveraging development principles and how to use them to build our automation frameworks. A quick intro before we get started. My name is Aditi Mulay. I have been working in the field of automation for quite some time. Before that, I used to be in the development field. And just to give you an idea about how long I have been in this field, my first project that I worked in automation was with Selenium 1.11. There was no WebDriver at the time. I was using Selenium 1.11 at the time. So that's how long I have been working with automation. I love this field. And I have been working in education, advertising, and currently I work for a government contracting firm called Carson Solutions. It's based in Northern Virginia. So I'm from the US right now. Quick way to reach out to me is LinkedIn, Twitter, and we may not have time to have question and answer session today because you guys will be in a rush to get your lunch. So if you would like to, please welcome and meet me at the office hours in the office next door. With that quick intro out of the way, let's quickly get started. This is my agenda for today. Just a few things. First is I just want to talk about automation framework, what I mean when I talk about automation framework. And then comes the development principles. So the development principles, as you might be aware of, I'm going to talk about the object-oriented programming principles. And the big part I want to which I hope it comes across, is it's not just an intro to OOPS. I have some actual examples which I have used in my automation frameworks. And those are the things I would hope that you take away when you leave this talk. And that's a quick look at the agenda, and let's get started. So automation framework. A lot of times when I talk to people and I ask them, what type of automation framework are you using? Mostly the answer is just Selenium. So that's a great one, but it's a great tool. It doesn't completely give you access to the complete testing framework that you might need. You might be doing back-end testing, API testing, so there's a lot more involved in the framework. But yes, the first building block of my automation framework is always Selenium. Also, one thing I do is, rather than using Selenium directly out of the box, most of the teams I have worked with, they use a wrapper on top of it. Just makes it easier for us to combine 3 lines of Selenium code into 1 line, and that's how we use our wrappers. I have mostly used Selenium. If I want to do it out of the box, I used it like a proof of concept, just to say that, oh, I want to test this application. I will write a few lines of Selenium code just to show my managers that this is how we can use this particular tool. So that's the first building block. Another thing, and the most important one, is our test data. All our tests require test data, but it comes in different formats. You can get your test data from XML, Excel, JSON, CSV, properties. I don't know, there may be another ways of even getting test data. So getting that test data, retrieving it from those files, and then using them in your scenarios or test cases, that is one thing that also needs to be part of your automation framework. Then comes utilities. So these are what I call my helpers. You always need to have tons of these helpers to get your automation framework up and running. File readers. So file readers, I mean not just the data file readers, but if your application is uploading, downloading PDF files, you need a way to read those files. Databases. If the way your application is supposed to be tested is check something on the UI, and then make sure that's the same data that is stored in the database. In that case, you will need some database utilities to make those connections, data pooling, and also to run those queries, validation queries. And APIs. You can have your own API test harness, or you could use those APIs and web services as part of your data setup, data teardown methods. So you will need some sort of client for that. And lastly, and there's tons of other things, but date formats, string comparisons, a lot of things that we do as part of our automation testing, those can also become part of these utilities. Now, this is one important thing, traceability. When we write test cases, it's not just about writing a test case and being done. You have to always map it to a particular story or feature in your code when you're coming up with those requirements and testing things. So tagging is an important part of that. You can use tagging to be sort of like a live documentation. It can say, oh, this particular one is related to Jira ticket so-and-so, that's one way. Or this particular scenario is related to this module. Or this scenario is a positive test versus a negative test. Or a smoke test versus a sanity test. You can add any number of tags to your test cases. And that, again, becomes your documentation. This feature is provided by Cucumber also, if you're using that. But if not, then you can actually build your own tagging framework. Then, other thing of tagging, other importance of tagging is execution. You can use this as a subset of tests that you want to run. You might have 100 tests out there, but you need to run only 20 for your sanity check. So you can tag those tests as sanity and just run those tests. So this is one important part of your automation framework. And once you're ready with the execution part, comes the reporting. Reporting, as you know, we get screenshots from a lot of tools out there. There's JUnit, there's an n number of other tools, Cucumber, which provides its own reports. But sometimes you need more than what those reports are providing. In my case, we wanted a capability to do video recording of every test that runs. So I have like small video files generated at the end of my test. This is helpful when I have like 100 tests out there, and I don't have the time to babysit each and every one and look at them how they are running on a regular basis. So in those cases, when there are failures, I just go back to view the videos, and I can figure out where exactly in the test case or on the UI my test failed. So that's, again, a cool capability to have as part of your automation framework. And then, last but not the least, browser management. Selenium Grid provides us this facility already, but you need to make sure that your application, your automation framework is configured to use that capability out there. So if you look at all these things, you can see that that's a lot of coding that we have to do. And it's not something that we can do on day one and say, by end of the day, I will be done, my automation framework is ready, and I can start testing, writing tests for that. This one requires a little bit of design review, design architecture, and lots of coding. So that is where the idea for this talk came in, that we are doing so much coding. The coding is almost comparable to the one that a software developer does for his application code, and they use their development principles. So why can we not use the same thing on our automation frameworks while we are designing them? So here's a look at, oops, sorry for that. OK. Here's a look at the object-oriented principles that most of the developers are using. They are using this for languages like Java, C#, and even though I'm talking about these OOPs in terms of Java, that's where I have worked mostly, you could take some of these examples and bring them back to your scripting tools like Python or Ruby also. So even though they are object-oriented, not object-oriented programmings, you can still leverage the same examples in your scripting frameworks. So these are the 4 main pillars of OOPs. We are all fond of acronyms, so OOPs is the way to go for this. Abstraction, encapsulation, inheritance, and polymorphism. These are the 4 pillars, or the fantastic 4, as I call them, in our building frameworks. If time permits, I will like to take just like 2 minutes to talk about the dry principle. But the most important ones I want to convey as part of this is the OOPs ones. So let's get started with abstraction. This is the scientific definition for abstraction, process of hiding all data, but the relevant one. And that helps with reducing the complexity and increasing efficiency. But what does it mean in sort of like layman's terms for me to understand? And this is what I understood from that. Start off simple, but provide space later on to add more complexities. Okay? So let me give you an example of this, some real-life example which happens in my household. It might happen in yours too, but this happens in my house quite a few times. I have a son who is into reading, and he loves playing video games. So half the time, I would say, not even half the time, 99% of the time, his mind is thinking about the next Percy Jackson adventure or what he's going to do in Minecraft, and so on. So he's a pretty busy guy that way. So one day, I had this chat with him. I said, hey, it's been a long time since I haven't done any baking, and I love baking cakes. So maybe tonight, since I'm done with my presentation preparation and everything, how about I get, let's bake a cake. And let's bake actually 2 cakes, not just one. One with a vanilla flavor for you, and a chocolate flavor for my younger daughter. And can you help me with that? And can you just grab the cake flour from the pantry and the eggs from the fridge? So being the good kid that he is, he immediately jumped up from the sofa, ran in towards the pantry, opened the door, and sat staring inside for quite a long time. And then he comes to me and says, "So, Mama, what exactly did you want me to get from the pantry?" So that is when I realized that I thought it was a conversation, but it turned out to be a monologue. In that whole monologue, he didn't get what I was trying to get him to do. He lost track of the main goal I wanted to achieve, and he just was like, okay, I have no idea what she wanted me to do here. So in that case, it would have been much easier, much better if I had told him to just say, okay, can you just get so-and-so items from the fridge? And that would have been much more efficient from his point of view. So anyways, basically this is what happens even in our software field. We are trying to put too many details into our design. Too many details are going into our requirements and so on. And that causes a lot of problems, because then we sometimes lose sight of the goal that we want to achieve. So that's where abstraction comes in. And the best example of abstraction is in our Selenium WebDriver. How many of you here have taken a look at our Selenium WebDriver code? Can you show me? Okay, I can literally count them on the fingers of my hand. So as we know, we don't need to look at our code because the Selenium WebDriver is so cool. They have enough documentation that we don't need to deal with the code. But the best example of our abstraction is right there in our, oops. Okay, there it is. This is an interface which is our WebDriver. This is a quick peek. I have actually sort of moved a little bit code around so that it's easier for me to place it on this slide. You can see 3 methods out here: get, close, and quit. And all of us who use Selenium are almost very familiar with these methods. Get will open up a new page with the URL specified. Close will close that browser window. And quit will stop the driver itself. So these are the 3 methods which are really important to all of us, which we all use. But none of us needs to know the complexity of it, how they are implemented, how actually does this work. We don't need to know as long as we know that it works. So that's why this particular entity is called an interface, where you are declaring the methods but not giving all the details out here. Okay? So you're hiding the details from the user. Now, where exactly is that detail in? So if you look at the Selenium code, you will see that this is the structure of it, very basic high-level structure. You have something called as a remote driver. This is the class where all the complexities are there. So the high-level big picture is in the WebDriver, but all the complexities, the implementations of each and every method that we use is in the remote driver. And most of us would not even have been aware that there is something called as remote driver unless we looked at the code as such. We just deal with the WebDriver, which is what we are interested in. So this is how abstraction works. You take away the complexities, and you give them a simplified structure to then build on. Now, when Chrome driver and Firefox driver come into picture, they don't need to define the same code again. It's already there in the remote driver. They just extend the remote driver class, and they're all set. So this is one example of interfaces in WebDriver, which uses abstraction concept. But this was sort of a ready-made example for me. I don't need to do anything for this. It was already written by the Simon and friends. So what did I do when I had to deal with abstraction? So here is an example. I was given a requirement where I had to write a report. JUnit already provides report, as I mentioned. Cucumber provides those reports. But my team needed something more customized. They wanted more details added to the report which was generated after the tests were executed. So I was told to write a report in HTML format, and some additional data was supposed to be added to that report. So I was like, okay, let me get started immediately. I could have started off with just one class, which has my complete implementation, getting the data, and putting it into an HTML file. Excuse me. So that was the easy way. But then I was thinking that what happens? Today they told me it's an HTML report. Tomorrow they can come by and say, I need an Excel report, or I need it in a PDF format. So I wanted to design it in such a way that in future, when the requirements change or there was an enhancement required, my same code would still work. So this is what I did. I created a class called report. It has 2 methods, generate report and convert to format. I already implemented the generate report in that report class. That method was basically, it was taking all the data I wanted and putting it into a map, a key value pair format. So that's all that method did. The convert to format method was the one which I kept abstract. And let me show you the piece of the actual code out here. It's again pseudocode, since it's difficult to put everything in one slide. So what I did here was, as you can see, generate report will put everything into the results map variable. The other method, convert to format, for the report class is abstract. No implementation in that. No complexities are there in this class. The complexities are in the report IMPL class, which is where I'm actually implementing the report. So, convert to format. Now, this one was a very straightforward method initially. I just had one entry argument in there, which was HTML. When it was HTML, I call a method called generate HTML. Okay? So that's the easy part for me. Just write one method where I just get the data from the result map and place it into the HTML file. But then, in future, if someone comes with a different format, all they will have to do is add another case statement for Excel or a new statement for PDF, and they can write one more method which implements the PDF or Excel format. So that way, you are actually achieving that basic infrastructure is already in place, but you are giving the flexibility in future to expand your infrastructure in whatever direction your team wants it to go in. So this is one example of abstraction. Another one, which is not, this is very explicit, I would say, example, where you actually say abstract, or you call an interface, and so on. But we are all using abstraction in our regular day-to-day code also. So when you're doing logging, you're passing in a bunch of data to your methods, username, password. You actually don't care about whether it is user A, which is logged in, or user B, which is logged in. It's an abstract entity for you guys. So that's how we are actually using abstraction in our test cases already. But this is just another example of using abstraction. So just in a nutshell, what we are doing, or what we are gaining from abstraction is we design very simple and then provide room later on for the complexities. So with that, we have our first OOPS principle completed, and move on to the second one. Encapsulation. This is my favorite one, and I would say one of the most common thing that almost all of us here use it. So let me quickly go over the definition. It basically refers to bundling of data along with the methods that operate on the data. And the three items below are sort of the characteristics of it. What you're doing in encapsulation is putting elements inside a larger abstract entity. You are revealing as little as possible. You're basically saying that if you need to know, then I will give you the information. If not, the information is hidden from you. And then it enforces correct usage. And the best example for this is page object model. How many of you use page object model in your frameworks? Okay, almost most of the room. So next time you're using a page object model, think about it as encapsulation. You're already using that particular utility, that principle in your automation frameworks. So as we know, page object model is pretty straightforward. This is one for the login page. Very simple, two elements that we have to interact with, the username, password, and then the third one is the login button. And to interact with those three elements, we have a method, login. Everything happens in that method. All the the element interactions happen in the login method. I just want to call out a few things in here. The ones highlighted in blue, when I'm defining the locators, I want to make them private because I don't want anyone else to modify them. There should be no need for anyone to change those locators. So that's why they are private. And this is a way of we are hiding the data in encapsulation. But the method, login, it can be called from any page in our application. And that's why it's made public. So we are hiding what we don't want people to change. And people, I mean other automation engineers, I would say. We don't want them to modify the locators, so they are private. And login should be there public, available to each and everyone in the team. Now let's take a look at another example. This is a list page where it's a very straightforward page. I just have one text field on the page and a search button. What it does is whenever I enter a text into the text field, and I click on the submit, it gives me a bunch of search results. Very straightforward. Now, I have written it in a different manner. I have provided two methods out here for the element interactions. One is the set search text and the submit. It is pretty straightforward. Again, I have a common method called perform search, where I can click perform both the actions simultaneously. I always prefer to have a consolidated method for all the elements because, say, for example, you have a page like a user data entry page where you have 10 fields that you need to enter, and then you have to submit. When you're actually implementing that in your step definition, you will be actually calling 10 different methods. To avoid that, it's better to place it in your page object class itself. So that's the consolidated method I have out here. But the advantage of having individual methods for every element is like this. Say, for example, I want to run a negative test, and I want to just say, I don't enter any data into the text field. I just want to click on submit, and on submit, I should see an error message showing up. So that's where that method on line 20 will come into picture. You just click on submit, and you're all set. Also, there are other ways of writing the perform search method. You can put some case statements in there. Depending on how your data comes in, you can either enter the value, interact with the element, or not interact with the elements. So there are different ways of writing your page object. A couple of things I want to just call out for page object is, a lot of times people say that, why should I write a whole class when I just have 2 elements to interact? I could easily write those lines of code, driver.findElement in my test implementation, and I'm all set. Why do I need a page object for this? And the big reason I give this is like this. You know your application, so you know exactly what to call, where to call, and so on. But anytime you get a new member in your team, you're looking at other page objects, and only for that search page, he cannot find the page object. Where exactly is he going to look for that page object, or those elements interact with? Is he going to write the same driver.findElement methods in whatever test case he's going to implement? Then you have the code duplication. Maintenance becomes an issue, and so on. So even though it feels like you're writing 10 lines of code for just 2 field elements, long-term maintenance will become much, much easier if you do that. And as most of us know, the biggest drawback for automation is the maintenance cost. A lot of teams are really hesitant to go into automation because like, oh no, then we have to keep on maintaining this. It's not like a one-time thing that we can do. So keeping your maintenance costs low is one of the goals, and that is where the principles are helping us. Other thing is, someone also told me recently that, oh, instead of having, we call this page object model as a page repository. On that page, you have all the elements on that page, UI page, actually mapped. But instead of that, how can I, instead of going that way, how can I not try another way where I come up with a module repository? So by module repository, what they mean is if they have 10 pages in, say, a user management module, all the elements on those 10 pages are co-located in one huge file. So again, I would not suggest that approach. At least in my case, whenever I have tried to use that approach, we ended up with a huge debt, because username on page 1 and username on page 10 might be different. And then again, a new person or a new team member who inherits the code from you comes in, how is he supposed to know which page, which username belongs to which page? So maintenance costs grow higher if you move away from this model. So this is the best example of encapsulation, and these are the advantages that we gain from using this page object model. We are hiding the data, which we don't want people to modify. We are giving them sort of hooks to look into, the public methods. Those are the ones that they can actually use for their automation. It helps easier maintenance, because we know whenever something changes on UI page, we know the exact page we have to go and make the change in. And the code is much, much readable. You really exactly know where to go when particular pages are being modified. So these are some of the biggest advantages of encapsulation. And then we move on to the third pillar, or the third item on the Fantastic Four list. This is inheritance. Today morning, we had a quick bio lesson from Simon about genes, DNA, and everything. We all know we inherit our characteristics from our parents, our looks, our temperament, and all these details come from our parents. So the same logic works with software also. We can actually make sure that we create one entity, and a second entity which is inheriting it from the parent has the same exact custom behavior of the parent. So let's go back to our favorite page object model again. Now, it's the same example, but I have made some changes out here. I have a page class, which is my base class or the parent class. 3 methods in there. One is for checking the header, one is for checking the footer, and the highlighted one sort of combines both of them and adds some assertions in there. So ideally, in your application, your footer and header should be very consistent. So your footer is same on all the pages. I have just put some dummy code out there again. And you are just making sure that you are on the right page. And that is what the page object isPageLoaded method is giving us. Assertions. In case you're not on the right page, the assertions will fail, your test fails immediately. So this is my parent class. Then I wrote my list class to extend the parent, which is page class. And all I did was the isPageLoaded method that I have in my parent, I just used it in my child class to make sure that when I'm performing a search, I'm actually on the right page or not. So this way, I have inherited the behavior or the characteristics of my parent into my child class. And it's not just this particular class, list page. If I have 10 other page classes, all of them, I can still use the isPageLoaded method. The only difference is I pass in a different string for every page class that's out there. So if it's a login page, I can just pass in a string called isLoginPage. If it's a user management page, I pass in a different string, which is my header, and I'm all set. So my code is basically coming from the parent class, but I can still use the same method across all my page classes in there. So this is one example of inheritance. What inheritance actually gave us, as you could see, is I wrote the code one time, I used it in my 100 other pages. So we are reusing the same code again and again. Your code is centralized. Now tomorrow, if some developer comes in and he changes the header text, so that you saw out there, instead of by ID, he changes it to by name or something else. All I need to do is just come to this page, make the change. Rest of my test cases, rest of my automation framework is not impacted at all. So that's one advantage of inheritance. And again, inheritance is normally used to keep your file counts and code count low because of these attributes. So this is our third principle that we use in our automation also. Then comes polymorphism. This is actually the tricky one from my point of view. It's a little bit complicated, and I have tried my best to give some good examples out here. What polymorphism basically means is many form. Poly means many, morph means forms. So your software, your code can exist in many forms. That's the meaning of this. And here's the actual definition of the condition of occurring in several different forms. Now, how can this happen in our software? How can it change behavior? So let's take our example, again, our page objects. Now I have added a method called logout. Every page that on your application will surely have a link to logout of that application. And in my case, I just use a simple strategy by ID, find out the element logout link, and then perform the click action. Very straightforward. Every page class which inherits this from the page will have this logout method. Now, imagine a case where the developers are not following the development principles. They are not reusing the code. They are not being consistent with their strategies. And they say, I'm creating a new page called list page, and I'm going to name the logout link on that page something different than the rest, just because I want to. So they come up with the strategy that on the list page, the logout link does not have the ID as logout. It has an ID as list logout link. So out of 100 pages that I have in my application, 99 of them have the same ID as logout, but one page has this difference. So in that case, what I need to do is I just need to write the logout method, override it in my list page class. So that's what I have done. If you can see the annotation out there called override on line 29, the overriding is a way of changing the behavior. The method call is the same, but you are still changing how that method particularly behaves. So what I did was just change the ID, and I'm all set. So anytime in my test cases, when I'm calling, say, user page.logout, it will call the parent class method. Anytime I'm using list page.logout, it will call the child class method. So that way, you are overriding the method. You are sort of overriding it to behave in a different manner. So this is how polymorphism works in our automation. Now, another example of polymorphism is something called as overloading. So in this case, as you see, both the logout methods, their signature is the same. It's public, void, logout with no arguments. So they're exactly the same. The internal behavior is different. Now, this other case, you will see something different out here. This is a navigate to page method. We, most of the time, will need some methods like this, where we have a page name being passed in. You have to click on the page name, and you reach the page that you're interested in. It can be in form of tabs, or it can be a left-hand menu panel that you're clicking on to reach the page you're interested. So I have a method for that, navigate to page, which takes in the page name. Now what happens here is, whenever this method is called, I click on that link, and the page opens up. But not all pages might be that easily accessible. Some of them I have to go through some breadcrumbs, basically. I have to click on 2 links to reach the page of interest. In that case, what I could do is, for that sub-page, I could actually write another method with the same name, but a different signature. And by signature, I mean the number of arguments that I'm passing, or the return value of that method can change. In my case, I just changed the signature by passing in 2 arguments, the main page name and the child page name. So internally, what my code would look like is I click on the page name first, then I click on the child page, and that way I reach the page of interest. So why would I do that? There is another way of doing it. You could just write a completely new method saying navigate to list page instead of just navigate to page. That's one way of doing it. But sometimes you want to have that consistency for people to understand. When I say navigate to page, I can do this action. In case there are 3 pages that you have to go through, you could again change the signature and just say pass in the 3 arguments that you need to reach the page of interest. So that continuity in your coding style, that is also something which is helpful for your team members, because they know the navigate to page is taking them to XYZ page. So that's where polymorphism comes into picture. There are a lot of other examples with polymorphism that are actually very difficult to sort of present in the next 5 minutes. But if you want, you can come talk to me, and there are a few examples that I can walk you through. But what polymorphism gives us is code is being reused. My same method, logout method, or my navigate to page method, I'm using it throughout my application. They are still flexible enough that they can be modified with new enhancements that come in. Today, your page was coming with 1 click. Tomorrow, your page might be coming with 2 clicks. So you still have that flexibility to change your methods accordingly. So this is one way of using polymorphism in your automation. With this, we actually conclude all the fantastic fours of OOPS. Since we have a couple more minutes, I just want to talk about dry principle. This is something all of us must be familiar with. It's called KISS also. A lot of different names for this, but this is what I always identify with. Don't repeat yourself. This is something really important in our automation framework. Not just automation, I would say, even in application code. When you're doing code reviews, when you're checking out code written by someone else, if you see a few lines of code which are literally like copy-pasted from somewhere, if you see that, you have to say something and do something about it, basically. That's what this principle actually talks about. Repeating code is actually a big drawback because, again, the cost is maintenance. If you change something somewhere, you have to find all the search and replace items and then make those changes. And search and replace is not always that easy, as we all know. So don't repeat yourself is something where if you see some common code, you need to either move it into a common utility, into a common page class or a parent class, and that way you can avoid maintenance cost and you can get code reuse out of that. And here are a few examples that I literally came up as I was working on this presentation. Navigating to a particular page. It can be part of a common utility, or it can be part of your base parent class. Checking if a page is loaded or not, something we always need to do as part of our testing. Logging in, logging out, data retrieval, validating file contents. These are just a few of the examples. There are tons more where you will need utilities. And those are sort of the ones which I even talked at the beginning. Those helper classes that we talk about, some of these things can end up in those helper classes. So this is a very important part because, again, maintenance, maintenance, maintenance. That is something which always brings us down. So if we can avoid that, we sort of have won half the war in this. So with this, I would almost like to conclude my presentation by summarizing what have we achieved till now. I hope it's not just this. I hope you don't just use the words like encapsulation and polymorphism when you go out. You actually remember the examples that went with it. And the whole point of these examples was to achieve these things. Code reuse, flexibility for code to enhance in future, and low maintenance cost. So this is what I wanted to present in front of you. Thank you all for listening to me. Thank you.